Right, so today we're really diving deep. We're looking into the life of Évariste Galois.
Évariste Galois.
I'm already seeing, like, French Revolution vibes, and I know we're going to get into his life.
Very much so, yeah. He's a fascinating figure, and you're right. His life, although very short, is very much caught up in the politics of the time in France.
Okay.
Early 19th century France, a lot of turmoil.
Okay, so let's start setting the stage then. 1811, Galois is born.
1811, yep.
His family is, they're politically active. His dad's the mayor, big Napoleon fan apparently. But his mom is really interesting to me. She's the one who takes, like, the lead in his education early on, right?
Yeah, and she sounds like a really, really bright woman, very interested in the classics. So she teaches him Latin and Greek at a young age and really kind of, imbues him with this real love of learning. But also she's skeptical.
Oh.
She's skeptical of authority, particularly of organized religion. And so she kind of instills that in him as well from a young age.
So we've got young Galois, he's going to be a little bit of a rebel at heart already at this point.
Well,
He gets sent to Louis le Grand, this very prestigious but very strict Jesuit school. Like, what was the environment like when he gets to this school?
yeah, so Louis le Grand in the 1820s was a hotbed of rebellion.
Oh.
I mean, students were constantly staging protests. They were refusing to recite at lessons. They were boycotting toasts to the king. Yeah, it was a very sort of anti-establishment sentiment at the school at that time.
Okay, so it was Galois, like, on the front lines, leading the charge.
We don't have like concrete evidence that he was a ringleader in these early rebellions.
Okay.
But I mean, you can imagine just being in that environment, especially with his kind of personality, already primed to question authority. It must have really influenced his thinking.
Yeah. Okay, so we're setting the stage here. It sounds like, maybe he's going to be this revolutionary, but he's also brilliant, right? Like, he's winning awards in classics.
Yeah, exactly. I mean, he was a really good student. He excelled in his studies. Like you said, he's winning awards in Greek, in Latin.
Yeah.
He could have had a very different life, frankly.
Totally. Yeah, if he stuck with the classics.
Right, exactly. He might have ended up a classic scholar or something, who knows? But it was math that really captured his imagination.
So what flipped the switch?
It's funny how these things happen. He has to repeat a year, right?
I don't know.
Yeah. And he ends up in a math class.
Okay.
And the teacher is this guy, M. Vernier. And this wasn't just any math class. This is where Galois gets his first real taste of higher mathematics.
Oh, wow.
So, for him, it's like discovering a whole new world.
And he just dives right in.
Oh, he dives in head first. I mean, he gets completely obsessed. He's neglecting all his other subjects. I mean, he's reading math books like they're going out of style. His other teachers are pulling their hair out. Even Bernier is like, Galois, I know you're brilliant, but you need to find some balance.
He's hooked.
He is. He's completely hooked. He's found his passion.
So Galois, I mean, he's completely obsessed with math at this point. But this is more than just a phase, right? Like, this leads to him actually, like, making some breakthroughs, even as a teenager.
Oh, yeah. This is where it gets really amazing. I mean, he publishes his first mathematical paper at 15.
15? Wow.
15 years old. Yeah, and not just on, like, some basic math. This is on continued fractions.
Okay, I have to admit, that sounds a little intimidating.
It's a pretty advanced topic.
Yeah.
Yeah, I mean, most people don't encounter that until much later in their mathematical studies. Think about it like a fraction, but instead of just having two numbers, you have a fraction inside a fraction inside a fraction.
Okay, so fractions on steroids. But the point is, like, he's already working on this really high-level stuff, even as a teenager.
Absolutely, yeah. And it's about this time that he really gets captivated by this problem that had been bugging mathematicians for centuries. This big unsolved problem.
Okay, which is?
Figuring out whether any algebraic equation could be solved by radicals.
Solved by radicals. I'm going to need you to break that down for me a little
Yeah, no problem. So when we talk about solving an equation, we're talking about finding its roots, basically the values that make the equation true. So, simple example,
Yeah.
x sum of 1 equals 0. The roots are 1 and minus 1, right?
Okay.
So we can find those roots using basic operations like adding, subtracting, multiplying, dividing, taking roots,
Okay.
like, square roots, cube roots, those kinds of things.
Okay.
And those are radicals. So the big question was, could you always do that? Could you always solve equations, even really complex ones, using just those basic operations? Oh, interesting. So it's like you can only use these specific tools, and some of these equations, they're like, maybe you need a different tool.
Exactly. And some mathematicians, they had already started to figure out that some equations couldn't be solved this way. Like this guy, Niels Abel, he proved that equations with a degree higher than 4, that means like the highest power of the variable is 5 or more, those couldn't always be solved by radicals. But Galois, he wants to go deeper. He wants to understand, like, what is it about the structure of these equations that makes them solvable or unsolvable?
Okay, so he's not just trying to like brute force solve these equations. He's trying to understand like the why behind it.
Yeah, exactly. He's like, what's the underlying, the DNA of these equations?
So how does he do that?
He comes up with this really revolutionary idea, which is using symmetry to understand equations. Symmetry, like how symmetrical a shape is. I don't know how you would even apply that to, like, an equation.
Yeah, it's a great analogy. So think about like a square, right? You can rotate it 90 degrees, 180 degrees, 270 degrees. It still looks the same.
Right.
Those are its symmetries. And Galois realized that equations, they have symmetries too. You can rearrange the roots of an equation in certain ways, and the equation itself doesn't change.
Huh. Okay, so you can, like, move things around and it's still, like, essentially the same equation at its core.
Exactly. And so he developed this whole new concept called group theory.
Group theory.
Yeah. So basically, he showed that you could associate a group, which is like a set of symmetries with certain properties. You could associate one of those to each algebraic equation. And this group, we call it the Galois group. It tells you a lot about whether the equation can be solved or not.
Okay, so walk me through that a little bit. Like, how does it actually tell you that?
So the bigger and more complex the Galois group, the more symmetrical the equation is, and generally the harder it is to solve. But if the group has a certain structure, if it's what we call solvable, then you can kind of break down that symmetry step by step, and you can solve it using those radicals we talked about, those basic operations.
Oh, okay. So the Galois group is like it's like a blueprint for whether you can actually solve it with those tools that we talked about.
Exactly.
Yeah.
That's a really good way to put it, yeah. And here's the real breakthrough. Galois proved that some equations, they have Galois groups that are so complicated, so messed up, that they can't be solved by radicals no matter what you do.
Wow.
Yeah, it was a huge discovery. It finally put an end to this centuries-old debate. I mean, mathematicians had been arguing about this for a long time.
So Galois, still a teenager, like, completely revolutionizes how we understand equations.
Yeah.
So, I mean, he's got to be celebrated at this point, right?
Yeah.
Like, papers published, awards, the whole 9 yards.
Well, unfortunately, Galois' journey to recognition was a little bit more complicated than that.
Okay, so we've got Galois. He's a teenage mathematical genius, right? Sitting on this discovery that's going to change the world. But instead of, like, accolades and celebration, things kind of take a turn, don't they?
Yeah, they really do. Galois' personal life kind of collides head-on with his academic aspirations.
It starts with his dad, right? This transcript mentions a smear campaign, even suicide. What happened?
Yeah, it's a really tragic story. So, in 1829, his father, who's, remember, the former mayor, he becomes the target of this really vicious smear campaign, and this is orchestrated by a Jesuit priest.
Oh, wow.
Yeah, they're talking forged documents, public humiliation. It was just this relentless attack on this man's reputation.
That's awful.
It really was, and it proved too much for him. He ends up taking his own life.
Wow. So Galois was only 18 at the time. I mean, to lose his father in such a horrific way, especially given, like, he's already kind of, he's already skeptical of authority.
Oh, absolutely.
This must have been devastating for him.
It was a turning point for him. Yeah, his distrust of authority just intensifies, especially toward the conservative government, the institutions that he sees as responsible for his father's death. He channels a lot of this grief, this anger, into his political activism.
Okay, so he's already kind of fired up, and then to make matters even worse, the July Revolution of 1830 kicks off in France. So now the country's literally on fire. Students are taking to the streets. Where's Galois in all of this?
Well, he's stuck. He's stuck inside Louis Legrand, the school director. He's terrified of the students getting involved in the uprising. So he basically puts the entire school on lockdown.
Oh, man, I can only imagine how frustrating that must have been for him.
It's like he's witnessing this revolution, this fight against the authority he despises, and he can't do anything about it,
Talk about adding fuel to the fire.
Yeah, and this is where he really dives headfirst into this political activism. He joins these Republican societies. He's writing, he's publishing articles, he's criticizing the school administration. It eventually gets him expelled.
Expelled? What for?
For accusing the director of treason.
Wow. So he was not messing around. But with all this political turmoil, the expulsion, how does he even have time for math at this point? I mean, he did make those breakthroughs, right? With group theory and everything.
He did, but this is where it gets really frustrating. I mean, he sends his work to the Academy of Sciences, and
This is for, like, recognition, right? Like,
yeah,
hey, look what I did.
exactly, recognition, publication. This is like the biggest deal for a mathematician. And they basically ignore him.
They ignore him. How is that even possible?
Well, there's this mathematician, Augustin Louis Cauchy. He was actually supposed to present Galois' work to the Academy.
Okay.
And for whatever reason, he never did.
Oh,
Maybe he lost the manuscript. Maybe he didn't understand it. Maybe it was deliberate. We don't really know. But the point is, Galois' work, it just gets buried.
are you kidding me? This is worse than the school director locking down the school. This is his life's work.
I know. It's awful. And of course, Galois, he sees this as confirmation of his worst suspicions.
Right. The system is rigged against him.
Exactly.
So what does he do?
He keeps going. He keeps working, refining his ideas.
Wow. Even with all of this going on.
Yeah, he knew he was onto something important, even if nobody else seemed to get it. But then, in 1832, at the age of 20, he's killed in a duel.
A duel. What happened?
The exact circumstances are still a little bit murky.
Okay.
We know it involves this woman named Stephanie, who may or may not have been the daughter of a doctor he met while he was, had been briefly institutionalized. But yeah, whether the duel was about her, whether it was political or some other reason entirely, we don't really know for sure.
So this incredible mind silenced way too soon. It's heartbreaking.
It really is. And the saddest part is, on the eve of the duel, Galois, he knows he's probably going to die.
Oh, no.
And what does he do? He stays up all night, frantically writing down his ideas in this letter to his friend, Auguste Chevalier.
It's like his last will and testament, but for
Yeah.
mathematics.
Yeah, exactly. He's trying to get everything down on paper,
Yeah.
make sure that his work doesn't die with him.
It gives me chills just thinking about it. This is a guy who knew how important his work was, even if no one else did at the time. And it makes you wonder, what else could he have accomplished if he had lived?
It's a question that continues to haunt mathematicians to this day. But even though Galois' life was cut tragically short, his work didn't die with him.
So someone finally realized what he had done.
Yeah. Chevalier, his friend, he kept his promise. He shared Galois' letter, the scribbled notes, with other mathematicians, and slowly people started to realize the brilliance of what this young man had accomplished.
You said it took a while for people to understand his work, right? Like, it wasn't an overnight thing.
Yeah, it took over a decade, actually. But eventually, it fell into the right hands. A mathematician named Joseph Louville, he recognized the importance of Galois' ideas, and in 1843, he presented Galois' work to the Academy of Sciences.
Wow. Talk about coming full circle.
I know. It's like even in death, Galois finally received the recognition that had been denied to him in life, and it didn't stop there. Today, Galois theory, it's a cornerstone of modern mathematics. It's used everywhere, from cryptography to physics. Galois' ideas, they've had this profound impact on our understanding of symmetry, of abstract algebra, even the nature of reality itself.
It's amazing to think that this one person who had such a short and troubled life could have such a lasting impact on the world.
It really is, and it makes you think, how many other Galois are out there? How many brilliant minds haven't had the chance to share their gifts with the world?
It's a reminder that we should always be looking for that spark of genius, even in the most unexpected places. And maybe, just maybe, we can create a world where brilliance like Galois is recognized and nurtured, not ignored and silenced.